I was about to do an SDXL workflow video. I went on CivicAI and saw there are new ControlNet models for SD 3.5, which is interesting. So I want to do that instead. So here is the Hugging Face for stable Diffusion 3.5 control nets. So you can find control nets newly 3 days ago. It says here on the Hugging Face that these were released. They are pretty large files that will have to load into VRAM, so you're going to have hardware that can run SD 3.5 as well as run this additional neural network loaded in 8.65 gigabytes. So on Hugging Face, you had to give them your contact information to download it. We are going to want to try first CANNY. I am most interested in the CANNY. We're going to try CANNY. Depth is also a good one. Blur, I have no experience with Blur, honestly. Maybe we'll look at that a different time. But we're going to look at CANNY to start. You're going to want to download this CANNY model. And we're going to need to download the SD 3.5 large FP8 scaled safe tensors file for SD 3.5 large if you have not already started out and made any SD 3.5 workflow attempts. We're going to want to have that model as well. You can get that on Hugging Face. Let's see what CivicAI has. They might have something interesting. We're going to click on... Yes, okay. So on CivicAI, this is how CivicAI interface works. You want to log in. It's worth it to register for CivicAI if you are already registered. It's a great site. In my opinion, the best for stable diffusion communities. Now we have SD. You want to click the filters button in the top right corner. You want to click model types checkpoint because we're going to search for SD 3.5 checkpoints. You could also go to Hugging Face and find directly from the developers site the basic SD 3.5. There could be something more interesting for us, however. So we're checking out CivicAI and learning their interface today in this example. Before we head into CANNY, we're going to look at how to set up the entire workflow from scratch. And I don't plan these videos out. I just go ahead, wing it, because that way you get to see all the steps as I encounter them and what you'll actually encounter. I'm checking out what they have available on here. We have downloaded the ControlNet CANNY file. I have also already downloaded myself the SD 3.5 large FP8 scaled safe tensors file. I'm just seeing what else they have on CivicAI for us. because I feel like, okay, I feel like they can offer something additional with all the people that release models on here in the community. Okay, we want to click SD 3.5 large, not SD 3.5. That's why I was not seeing it. Hmm. There's the absinthe model using negative LoRa's. And what you actually want is these FP8 models. The FP8 scaled model is what I'm using today. And this is a different variant released by this individual, ZDWW. So you have this option, but really, honestly, let's backtrack. Like I said, I'm not planning these out. I want you to see the process of uh, learning and discovering how to actually do this for a real person in the real experience, not some whitewashed YouTuber video. I'm not a professional YouTuber, as you can see. This is a small channel, so what we're gonna do is go to Hugging Face Stability AI page and get the model directly from the producer of the model, the developer, Stability AI. Stable Diffusion 3.5 collection. And this is going to be where you can get the full model. What we want is the FP8 scaled model, assuming that you do not have the hardware to run the full model. You want the FP8 scaled model. It will run more efficiently on more hardware. So we are going to look at that and find the FP8 scaled model as well. I want to show you this main repository. This is the most official file. Anything else is a derivative from the Stability AI versions. We're going to need various other aspects of this depending on what is baked into the file you get. You need different text encoders and things depending on what is in the file you get. Just a quick Google search, and I was able to pull up the comfy.org repository on Hugging Face with the Stable Diffusion 3.5 FP8 file. So we want to download this large, very large 14.9 gigabyte file, SD 3.5 large FP8 scaled safe tensors file. Save it. We want to save it into the ComfyUI models, checkpoints, SD 3.5 directory, which I make myself. You want to ideally organize your checkpoints. So you want to download this. I already have the same file downloaded. And I have the example workflow from the Civet AI uh, articles, which are for the CANNY workflow. I'm going to create my own workflow for you in front of you from scratch, modifying this to my taste, and you'll see the real world inner workings of Comfy, I guess, that way. If you're just running their workflow without dissecting things and looking at how it runs, you're just running blind code, and that's not what this is all about. This is all about understanding and building new things, expanding this, integrating multiple control nets, and bringing in image prompted adapter and combining them into one massive workflow. And that's where the fun comes in, and your creativity is the limit. Let's take another look at another resource. We have this announcement article from comfy.org blog about SD 3.5 support, which has good information on running SD 3.5 in ComfyUI, which is what we're doing today. So this is essential. There are two pages from ComfyUI that we want to have for stable diffusion 3.5 projects. There is the main announcement for stable diffusion 3.5. There is the new announcement that we're going to need for the ControlNet release, ControlNet model release from November 26, 2024, which supplies workflows, links to the models, etc. We need to assume we don't have stable diffusion. This is a fresh install, so I'm installing things as we go. This page has important links that it can be difficult to find the exact right files sometimes. This page has links to the clip files, which do text encoding for the conditioning, converting your text into conditioning using these models. We want 3 models, even though we can use the baked clip often, depending on the model and what's baked. You'll see in particular that the T5XXL FP16 model is 9.79 gigabytes. How large is SD 3.5 large scaled? That one right here is 14.93 gigabytes. So you have to assume that this T5XXL clip file is probably not in the model. If anything, they'll have clip L and clip G, which are the clip files for other models like SDXL, which does not have 3. With 3 models, you can use a different node that will allow you to supply 3 clip files. Rather than a baked one or a single one or 2, you can find the node for 3. So you want to download from this SD 3.5 announcement on ComfyUI, it'll have the links that are especially useful for ComfyUI. That's why we go to this page. It's ComfyUI specific information and links. So, and we'll use the resources already there. I'm not going to make a new resource right now for this or anything because it's already here. We don't want to reinvent the wheel. Download these clip files, and we want to have not the full large model today. We're going to try the large FP8 scaled and hope that the scaled model works properly with the ControlNet CANNY that we are going to build the workflow for one step at a time. The first step is download all the models, place the clip files into the proper directory in the ComfyUI folder. Models folder. And we need them in clip. We want clip L, clip G. I already have those. We have T5XXL as well, FP16, and then there's also, if you're lower on RAM, if you have less than 32 gigs, you can find T5XXL FP8 floating point, the precision, and the it's T5XXL FP8 E4M3FN safe tensors. So I'm going to copy those. You want all the clip files in your clip models directory, and you need to have the ControlNet model as well in the ControlNet directory. I've made SD 3.5, put the ControlNet CANNY, brand new model. It's large. I'm on a 3090 with 24 gigabytes of VRAM, so we'll see the performance. And I've already tried SD 3.5. I've learned we want to use the scaled FP8 with the clip, the ControlNet, and the checkpoint safe tensors file, all for SD 3.5 in the proper directories. We can now begin to form our workflow. I'm going to use a sample workflow here, but we're going to build this out new, fresh, from scratch, in order to more carefully dissect what is going on and see firsthand. This is something I do to practice and learn more about ComfyUI and stable diffusion, and it really does help improve your abilities when you practice building workflows and how it all interacts on the lowest possible level. And this might take a minute because we're going to not plan it. We're going to have a real world, first-hand, candid look at what it's going to happen. It shouldn't be too hard because we have this, and this is a very basic workflow. I have experience with ControlNet and CANNY, with SDXL primarily, but the concepts apply either way. Now, why not start with loading the model, the base model for SD 3.5? Load checkpoint. Make sure You select the SD 3.5 model in your load checkpoint node. I had to restart Comfy server for it to show up, not only refresh the page. I had to do both today. What's next? Let's learn how to build the ControlNet aspect before we build out the rest of the workflow. You could do it either way. Let's look at the ControlNet aspect. So let's see which one they use here. There are several nodes that you can use that are the apply ControlNet nodes. I usually use apply advanced ControlNet. It is more advanced. The Comfy core apply ControlNet has less options. It may be more likely to work with the SD 3.5 new model. They might work together to have day one support, or it was already designed around the things because it's the Comfy core relative to a third party node. I'm not sure how they get this node. We can copy over this apply ControlNet with VAE node, and this workflow was from this image on the Comfy stable Diffusion 3.5 announcement page. So you can find this workflow here to reference. I recommend referencing it, and building your own new workflow from scratch this way, as we're doing now. I'm mentioning that so that we can grab the node here and try to copy and paste this node. And we'll get the same node as this workflow to ensure we have a good apply ControlNet node today. I don't want the video to fail. Using my normal node that is untested, this is a candid first look at this brand new CANNY SD 3.5. We know we need to supply the apply ControlNet with VAE node with the ControlNet model. So we are going to use today the basic load ControlNet model node, and we are going to find right away the SD 3.5 large ControlNet CANNY safe tensors model. ControlNet can be hooked up to between the load control model node and the apply ControlNet with VAE node. What do we need next? Let's look at the apply ControlNet with VAE node and see what inputs are missing. Apply negative and positive conditioning are missing. Let's see the infrastructure of this more closely. I don't think you need conditioning 0 out, but we can try using it to ensure we have an equivalent or better workflow. We don't want to have a downgrade. And I'm seeing which clip text encode they use. We're just going to use the basic one, and we will supply it with the clip in order to achieve input of the conditioning, positive in one text encode box, negative in another. You can just use the baked clip, but that's not the best. It's not going to have the full power because it's not going to have that 9 gigabyte TXXL model because the file sizes aren't matching up there. The model for SD 3.5 isn't entirely text encoders, it's latents. Clip text encode prompt, clip text encode prompt. Okay, we have enough of those. What we want is the triple clip loader from Comfy Core. We're going to supply these straight away up to the clip as needed here, and select clip L, clip G, and the T5XXL file that you want to use. If you want to use less than 32 gigs of RAM, use FP8, E4, M3, FN safe tensors. Otherwise, for the full capabilities, you will be able to have better adherence to the prompts with more powerful text encoding, such as the FP16 model. Let's go back to the apply ControlNet node. We are loading the model. The apply ControlNet node will use the model to modify the conditioning data. We need to give the apply ControlNet node the data that is a data gained from pre-processing an image. You may have seen the video where I use pose data, for instance. You can see in that video the raw pose data being extracted and saved. In another video where I use pose data, today we're using CANNY data. We need to pre-process the image with the CANNY node. Sometimes we will use CANNY Edge node from the ComfyUI ControlNet auxiliary pack as well. That's what I use on SDXL. Today we're going to use CANNY. It corresponds with this node. We will connect the load image node. And this is going to be cool. We'll run my alien machine avatar with CANNY as I did the last time. We can look at the power of this. More powerful, way larger model. It takes longer to run, of course. We need to hook up the VAE. The VAE, we are going to use baked VAE for SD 3.5 in the model. What do we have? Okay, all of this is hooked up. We need to next begin to have the sampling. We need to supply the sampler with the model, the proper sized latent. That is important. Do not give it a random dimension of pixels or it's not going to come out proper. It has to be divisible by 64. It also has to have the proper number of pixels. Not just one or the other. It has to match up to specific resolutions under those requirements, generally in Stable Diffusion. I am honestly not sure if SD 3.5 is taking in new capabilities, but generally that is the issue. Many people hit a pitfall when they have the wrong size latent image. So we always work under the assumption, use to begin 1 megapixel pixels, 1024 by 1024 number of pixels, resolution, and you want all the dimensions divisible by 64. We must place the sampler, K sampler node. There are choices if you have the efficiency nodes pack or others already. And we're going to use K sampler efficient. If you want to use a decimal for the denoise, you use K sampler. If you want to use steps explicitly, which is a little more complicated to expand and understand, you can use K sampler advanced. I'm going to use K sampler efficient. It has internal VAE decoding, daisy chaining of samplers if you want to do multiple samplers. It will allow you to preview as it samples the image. You can see the image as it is being sampled, which the normal one does not do. Connect next the model from the load checkpoint to the model on the sampler. The conditioning from apply ControlNet with VAE, the modified ControlNet based conditioning, which is using CANNY data, pre-processed image data for CANNY, input to the ControlNet with VAE node, modifying this conditioning from the text encoder clip L, clip G, T5XXL, FP16 clip models, all input for the particular SD3.5 model we are working with today. We can hook up the modified conditioning to the K sampler. We need to supply, we can see here the latent image, which you can think of as an empty box of whatever dimension we need that is taking in things latent from the model, denoising them as we define. And the noise has been applied, we remove the noise, it leaves us with a new image based on all of these neural networks. And with ControlNet, you have multiple layers of neural networks. So we can get more impressive images under more control with control nets like CANNY we are trying right now. To finally place the latent image, find the empty SD3 latent image node. We will use the default 1024 by 1024 resolution just to begin. I have shown how you can use resolution calculators, convert the width, convert the height to inputs from widgets. We want the VAE in the ControlNet as well as the K sampler. We're getting close here. This is all filled in on the left. You see, you just look what's on the left for inputs required. What is it output? This has internal VAE decode. Set the decode to tiled if you'd like to use VAE tiled decoding. That will allow us to use this image directly rather than a VAE decode tiled node. If you want to use that, you need to use the latent into it with the VAE into it, and it's an extra node. This K sampler efficient from the efficiency nodes pack has it all integrated. You're supplying the VAE here, and it's doing it and allowing you to select which type of decoding you want. So we can use the image output directly into a preview image, and we want to hook it up but also have a save image. And I think we're very close to being ready. We are going to look at the K sampler in the provided workflow. It should be more optimized for SD 3.5. It's going to give you defaults on the K sampler you placed that are just the defaults. They're not SD 3.5 related. So the CFG value of 7 is a CFG value of 4 on the workflow for SD 3.5 provided. That will determine how similar the CFG will determine how similar the image you get is to the original images inside of the model, the latent images that are used, denoised, combined in different ways based on the neural networks, referencing points with weights derived from vector lengths, where things of different relationships are compared. Things with closer relationships have different vector lengths. Different weights are derived from that. Is my understanding of how this works on some degree. Different latents are grabbed based on the weighting generated from your text encoder. It will look at the text, see what points of data it can look at, and it will find the relationship between them and give you an output based on that. So we want to have the right CFG value so that we are not too far or too close. And it's different depending on the model. Exactly, these settings might be different between models completely. As today, the default workflow is different on CFG in particular. We want to denoise it completely. We want to have steps equivalent to the amount of processing power you have. You can raise the steps if you have a better GPU. We might put 25 steps instead of 30. The last thing will be fixing this prompt. Delete the negative. We'll put the image is in error or rejected. We can leave their clip. And I heard that this is not necessary anymore. Negative prompts aren't necessarily necessary. I'm just going to put it for tradition to just put it using this context language of or perspective of the images. So it's natural language. This, I'm going to put the image displays a crystal pink dragon and is hyper detailed. Just for fun, we'll do it that way. Everything looks hooked up. We'll try to run it, I guess. I'm nervous. My last videos, I got it first try every time live. I did not edit it. Let's see if it works. It's going to take a few minutes, but we'll know right away if any big error happens with the model. And it's going to take a minute, so I will have to see. Let's do it live, I guess. I just don't want to start rambling on while we wait and ruin the video. Loading the text encoder is taking a while. I'm using the full-size text encoder, FP16. If you want to shave time off, you can use the FP8 version. As I go on, I would find new ways to improve this. There is clip text encode SD3. This could provide a benefit. It allows different conditioning for the L, clip G, and T5XXL encoders. You can place this, and we can see here it allows different input for the conditioning for each encoder. That is the benefit of this SD3. And I think the SD3 works with SD 3.5, if I'm not mistaken. This will just give the same prompt to all three, creating a consistent image. People say one text encoder will impact the character, the other will impact the scene more generally. You'd have to experiment and see if that is the case, considering we all have different workflows, we all have different goals and requirements and standards of what we're accomplishing here with stable diffusion. Sorry it's taking so long. It's taking the negative, positive conditioning, sampling it. K-sampler node is activated. No errors yet. I wouldn't be surprised if we have an issue, but it looks correct. This is the first try for me with SD 3.5 CANNY ControlNet, making the workflow copied over in large It's a typical basic boilerplate workflow. You just want to use the SD3 latent image, empty latent image node to ensure things are given latent wise in the proper format for SD 3.5. You can use baked clip if you want, whatever. This looks like it's coming in cool. I think it might be working. Let's see. Well, we gave it a prompt of this. I'm not sure if it's working. Must be. Is it taking the color? Let's load a different image and see how it alters a result. And this is the first look for me. I'm taking you live. Don't blame me if their beta nodes and model are not what we get with SDXL. They're different models. This is all new to everyone. So let's see what happens next. To test this, I am going to give it this image. It looks more gold. It's less colorful. So we'll see if it picks up this sort of image and changes the result. The result will change either way because of the seed. Let's try this out. After that, we're going to hit Q. After that, we can try deleting the prompt and see if without the prompt it generates something equivalent to the CANNY. Because for me, CANNY works with the edges of objects and tries to recreate those edges and fill things in using the models. This is making a very good image, but I think it looks like it's not doing my typical CANNY effect. Why could that be? We're not getting an error. We have the right model for that, ControlNet. We have the right text encoders. Maybe this is proper and I'm just a noob. I'm actually going to run a test. I'm not sure. So we are going to have another K-sampler hooking it up with a bypass of the ControlNet, hook up the clip condition or the clip considered conditioning without the ControlNet conditioning, which is the modified conditioning we're working with CANNY. Perhaps it's working. I want to see if we can get a test and see the difference. So we've hooked up another K-sampler, hooked up all the nodes on the left. We're going to do one thing. We want to right-click, convert widget to input, and select the seed. And we're going to have that on both samplers. We're going to take the seed we give it both samplers the same seed using a seed node. WAS Suite has a seed node where we can give it the integer we want. we want to give both samplers the same seed so that we can get a better look at things with the test having the same input seed for the denoising process. The same seeds should generate equivalent images, and so we're going to see if the conditioning modified with ControlNet is having any impact, or we get the same image. Oop. Clip, hook up the clip was the last issue. I finally messed up and got a red box. Uh-oh, bad alien machine AI, you suck. And it's fun to mess with workflows and run these kinds of tests. You could, write out a paper on it if you were an academic level individual and have a scientific Socratic method type test. Scientific method. And we can use we have a mistake. Do we? Yeah. I'm going to cancel it. Remove this box. This is the positive. This is the negative. We had the conditioning wrong. Just double checking that. We have this image sampling in our test, and I have already have the result using the previews. The CANNY is working. It's a false alarm. CANNY is working with SD 3.5. It was hard to recognize with the abstract image I gave it. The alien machine AI image was abstract for picking up any resemblance between the two. The new image, we can see this angle here, this angle here of these dragon eyes correspond with this element here, this angle, primary elements of this image are utilized here in this image. It has used the image, pre-processed it with CANNY, gives it to the sampler, and uses those edges plus the text prompt to generate the new image, combining latent within the model using, the ControlNet neural network as an additional layer that really makes things more impressive. This is more artistic. This is more impressive. You can farm input images, feed it to the CANNY using whatever, if you want to use Flux, get better images for inputs. Even though it takes longer, you can get better images, use them as CANNY inputs to a different model if you want, or vice versa. And I'm very happy we have CANNY data that we recognized as having been applied properly. I got freaked out at first when it wasn't obvious, but I am happy with this workflow having worked to the extent it has worked. It is ready to be optimized, expanded, experimented with, etc. Let me know if you have any issues getting SD 3.5 to work, or if I can improve this workflow in any manner. Let me know my mistakes and what you think of the test. We're giving it the same seed. This was an extra step for the test. The same seed is given to both samplers, same conditioning now. this isn't an optimized workflow. You can go mess with the thresholds for CANNY, get a more detailed or more resemblance or less. Thanks for watching with Alien Machine AI.